Good morning, everyone. It's Miss Packard. I hope you're doing well. Today is Tuesday, April 7th, and we've got a new lesson for today. So, our objective for today is students will be able to graph geometric and arithmetic sequences. We are still in our exponential and logarithm unit, but we're going to take it back to the basics a little bit. Our agenda for today, in our video, we're going to have a do now, go over some vocabulary, and I'm going to give you some examples. Then for classwork, I'm going to post a set of problems that I want you to do on your own. I'm going to ask that you take a picture of your work and send it to me, or if you can complete it online, that's fine as well. Okay, so for the do now, what I want you to do is take a look at these problems, and the directions say, what is the pattern for each of the following lists of numbers? What should the next term be? So I want you to figure out the pattern going on here, and then what's that last number going to be? What's the pattern happening here? Etc. Pause the video, take a second, and do those on your own. See what you can do. All right. So what you should have found for our first problem is that every time we're going to the next number, we're multiplying by 3. So I'm going to write times 3 here, times 3. So if we're going to figure out the next number in this list, we need to multiply 27 by 3. So what is 27 times 3? That's going to be 81. If you already got these answers, feel free to skip to the end and just check the answers. Okay, my next sequence, 5, 9, 13, 17. I should see that each time here I am adding 4. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. Then finally, 17 plus 4 will give us 21. Our next problem is a little trickier. We start at 32, then go down to 16, down 8, down 4. So what's happening between each of these numbers? The pattern here, you can say this two ways. We're either dividing by 2, or we could say instead of divide by 2, we're multiplying by 1/2. Those two things are the same, right? If I divide 32 by 2, I get 16. If I multiply 32 by 1/2 or 0.5, I get 16. So I'm going to keep writing this, divide by 2, divide by 2, and divide by 2. My last term is going to be 2. And here, 54, 49, 41, 33, 57 to get to 49. What did we do here? We subtracted 8. Each time here, we're subtracting 8. So our final solution is going to be 32 minus 8, which is 25. So for our do now, we picked up on a couple of patterns, and then we determined what our next term was going to be. And this is going to lead us into our discussion for today. So each of these lists of numbers are actually called a sequence. So now we're going to get into some vocabulary. A sequence. We're going to define a sequence as a set or list of numbers in a particular order. So we have a set of numbers in a particular order is a sequence. If you'll notice, all of our examples in the do now, all of our sets in the do now are examples of sequences. So it's a list of numbers. An arithmetic sequence is a specific kind of sequence. In this case, each term in the sequence is the sum. And what does sum mean? Sum means we're adding of the previous term and D, which is a real number. So D is a special number in this case. Every time we have an arithmetic sequence, we're going to have a D value. So, for example, if I have the sequence and I start at 0, 2, 4, 6, 8, and this continues. What am I adding each time I go to the next term? So 0 is my first term, 2 is my second term, 4 is my third term. In this case, I'm saying plus 2 each time, right? So that would mean my D value is 2. D is whatever number we are adding each time in an arithmetic sequence. The key thing here is every time it's arithmetic, we're going to be adding or subtracting. All right. Our next definition for today is a geometric sequence. So a geometric sequence, similar to an arithmetic sequence, but one key difference. So we have each term in the sequence is the, now not sum this time, it's going to be the product. And when we have a product, that means we are multiplying, right? So each term in the sequence is the product of the previous term and R. So in this case, instead of D, we have R. For example, if I have the sequence 1, 2, 4, 8, 16, and it keeps going, what am I multiplying each term by? I'm multiplying the first term by what to get my second term? Multiplying this by 2. And then I multiply 2 by 2 to get 4. And I multiply 4 times 2 to get 8. So that means that my R value in this case is 2. For a geometric sequence, we have an R value. Maybe put a cloud around our D value up here too. Now, when we have an arithmetic sequence, we're adding and subtracting. But when we have a geometric sequence, we are multiplying or dividing. As you noticed in the do now, we had the example where, I'm going to bring it back, we were either dividing by 2 or we were multiplying by a half. We could also say we're multiplying by 0.5, a decimal. Multiplication and division both work here for a geometric sequence. They're just expressed differently, right? Okay, so these are our vocabulary words that are new for today, but you may have heard them in Algebra 1. Now we're going to go over some examples to meet our objective. Remember, our objective is to graph geometric and arithmetic sequences. So, my instructions here. Given an arithmetic or geometric sequence, graph the terms by using the x-axis to represent the term number. Okay, so what is a term number? When I have a sequence that starts here at -3, and then it goes -1, 1, 3, 5, We're going to say it keeps going. My first term is negative 3. So I'm going to write that my first term is negative 3. My second term is negative 1. My third term is 1. My fourth term is 3. And my fifth term just happens to be 5. That worked out pretty well, huh? So then, what I'm going to do when I have this arithmetic, or when I have this sequence, and we know it's arithmetic, think about that. How do we know it's arithmetic? What's happening between each number? If you said we're adding by 2, you're correct. So this is arithmetic. So what I'm going to do, once I'm given a sequence, I'm going to create a table. And I've already made this table, but when you're doing this on your own, you're going to create this table. This table, where we usually have the x side, right? And we said we're using the x-axis to represent the term number. So my x value is the term number, and my y value is the term. So my first term number is 1. My term here is negative 3. My second term is negative 1. My third term is 1. My fourth term is 3. And my fifth term is 5. Now, really, our final goal here is to graph these points. It's easier for me to graph points once I see them in a table, because now I have my x and y values, and I know that each one of these rows will be a point. So my first point will be 1, negative 3. So I'm going to go over 1 and down 3. And that's my point, 1, negative 3. Then I'm going to graph 2, negative 1. Over 2, down 1. Then 3, 1 will be over 3, up 1. 4, 3 will be over 4, up 3. And 5, 5 will be over 5 and up 5. So we have a graph of our arithmetic sequence using the x-axis as the term number. If you need to, rewind the video or go back, watch it again to make sure you know what's going on. All right, my next example, number 2, we have the sequence 1, 3, 9, 27. In this case, what's happening between each number? To get from 1 to 3, we could add 2, but are we adding 2 from 3 to 9? No. This would be adding 6. So that's not the same. And remember, with the definition, we needed the same term, that D term or that R. So in this case, we're really multiplying by 3 each time. And then I order my terms, so we know this is going to be geometric. When I order my terms, my first term will be 1. My second term is 3. My third term is 9. And my fourth term is 27. So now I'm going to graph. My first point is 1, 1. Then I have 2, 3. Over 2, up 3. Then I have over 3 and up 9. All the way up 9. Now, I don't think I'm going to be able to fit 427 on my graph, but we would know we would go 4 over and then up, 27. So I'm off the page. I'm up really high. So I want you to think about what these graphs look like to you as you're doing this on your own. If you need to, rewatch the video for other examples, or to watch these examples again. Good luck. Remember, I have office hours from 11 to 12 if you have any questions, or 6 to 6:30 on Wednesday in the evening. All right, have a good day. Let me know if you have questions. Bye.